Okay, lesson 3, last lesson of the chapter and of the school year, chemical formulas. Now, this can be a little tricky to understand. Work slowly with me, watch the video I attach, go back through it if you need to. We're going to be talking about how to name ionic and covalent, which we sometimes call molecular because remember covalent bonds form molecules. So we'll have ionic formulas and molecular formulas. We're going to name those, but also we're going to be writing formulas to a certain extent. Now, when you get to chemistry, you'll learn things like how to name acids, how to name polyatomic ions, things like that. So if you get to chemistry later and you're like, I don't remember this ever in 8th grade, it's because there's a lot we're not doing because we're not there yet. But you're going to learn the basics of naming your ionic and your covalent compounds. So the first thing is naming our ionic compounds. Remember, ionic compounds are those ones that give and take electrons. They're going to have a cation, which is your positively charged atom. They're going to have an anion, which is your negatively charged atom. Typically, this is going to be your metal, and this is going to be your nonmetal. Okay? When you are naming these, what you're going to do is write the name of that first element. Then you're going to write the name of the second element, but you're going to change the ending to "ide." So I'm going to show you an example of what that looks like. Now, we're only going to be doing binary compounds. What that means is binary means 2. These are going to be compounds that only have 2 different elements. You can have compounds with a ton of different elements. Again, we're working simple right now. So we're only going to be looking at things that have 2 different elements. That's what the monatomic ion means. That means that there's only one cation and one anion. We have something called polyatomics, which are just atoms that tend to group together. Things like hydroxide or hydronium. Remember, we saw that when we were looking at pH and pOH? Those are polyatomic ions, but I'm not going to teach you how we get the name hydronium or hydroxide yet. Okay, so we're going to start with writing formulas. So when it comes to writing formulas, you are going to need to know something called the charge of an atom. How you figure out the charge of an atom, you can pull up a periodic table with me here if you would like. I'm just going to sketch one. You can go ahead and Google one if you want. Charge of the atom is based on its group. So remember we have groups 1 and 2 here, right? And then we're going to have groups 12 through 18. 13 through 18 over here. So your charge is how many electrons you gain or lose. Because remember, like in group 1, those guys want to lose electrons. And if you lose an electron, you're more positive. You lost something negative. So these guys are going to have a 1 plus charge. The next group, they want to lose 2. So they're going to have a 2 plus. These guys way over an 18, they're going to not have a charge. They don't want to react with anything. They have their 8. Whereas group 17, they would want to gain 1, so they're going to become 1 less negative. So you would need your periodic table to figure out, okay, how many more do they need or how many more do they want to give away? The transitions here in the middle can vary. Some will have 2, some will have 3. So as for where you are right now, you'll never be asked to figure out what that is. You'll be told. So with ionic compounds, we need to know the charge because that's what's going to help us figure out what the names of these compounds are and what the formulas are. We'll start by writing a formula. So let's say we have sodium chloride. Now, we've used this example a million times, so you probably already know the formula, but I'm going to tell you how we know. First thing we're going to do is you're going to use the periodic table and figure out where sodium is. I know sodium is in group 1, which means that it wants to give away 1 electron. It's going to have a charge of 1 plus. Chlorine is in group 17, which means it wants to gain 1, which means it's going to have a charge of 1 negative. Those charges are balanced. Since they're balanced, all I have to do is write my chemical symbols. Now I'm going to show you what happens if they're not balanced. Let's say I had sodium oxide. Sodium is still in group 1. It's still going to have that 1 charge. But oxygen is in group 16, which means it needs 2 more electrons, because it only has 6, because it's in group 16, which means it's going to have a -2. Since these aren't balanced, there's 1 more negative charge than there's a positive charge. That means we'd have to have 2 sodiums to make up for it. So now it's charged the same because we have 2 positive charges and 1 oxygen with a -2 charge. All right, I'm going to do another one of these. Well, let's say I'm going to delete all of that because I want to be able to have some space here. Let's say that I want to do, let's mix it up and not do a sodium. Let's say that I want to do beryllium. And again, you can be looking at a periodic table with me here if you would like. I just know where most of these elements are found. Beryllium iodide. Beryllium is in group 2. It is going to want to lose 2 electrons, making it positive. Iodine is in group 17, which means it only wants to gain 1 more. So in order to balance it out, I would have 2 I's. We'll do 1 more. Let's say let's do potassium. I have potassium. Let's do sulfide. Potassium is also in group 1. So it's going to lose an electron and become positive. Sulfide is in group 16. So it's going to want to gain 2. So to balance it out, I'm going to need 2 potassiums for every 1 sulfur. All right, so that's how you're going to name ionic ones. For ionic ones, you're going to need to know what's the charge and use that to balance the charges because you want neutral compounds here. It's easier with molecular. So when we get to the covalent ones, it'll be easier. Right now, you just need to look at your periodic table, which you would be given on the test, to figure out your charges. Now, the naming for ionic compounds is much easier. All you have to do is look at the elements that are here, and again, you will be given a periodic table, so you won't just be asked to memorize them, but you might start to get the hang of it. Look at the elements here. You're going to list the first one, the cation. Li is lithium. And then we have chlorine here, but you're going to change the ending to have a suffix of "ide." So instead of chlorine, it will be chloride, lithium chloride. That's it. All right. Just make sure when you look at it that you know whether it's a covalent or an ionic bond. I'm going to tell you on this test to either name this ionic or molecular or covalent, like I'm going to tell you, but in the future you won't always be told. So you can know based on, well, this is a metal, this is a nonmetal, So this is an ionic compound. All right. One more I'll do for you before we move on to molecular ones. We can have, let's do calcium. Let's do this. Now, let's say we have calcium, and this is phosphorus, so it would be calcium phosphide. Now, this one has a 3 and a 2. I kind of want to show you how we get a chemical compound like this. So if you were to look on your periodic table, calcium has a charge of 2 because it's in group 2, and that means that it's going to want to lose 2 electrons. So since this has a charge of 2, phosphorus is in group 15, which means it's going to need to gain 3. So how are you going to get those to balance out, right? If you add another phosphorus, you end up with a 6 charge. If you add another calcium, you end up with a 4 charge. Still not the same. So you need to figure out, well, how many do I need to add for them to be common? Think math, common denominator. A common denominator of 2 and 3 is 6. So if I have 3 of these, that gives me 6. And if I have 2 of these, that gives me 6. There you go. That's how we would get that formula. I just wanted to take a second to pause and show you how they got that. Now, this is a flow chart for naming ionic compounds, but this here has 2 types of compounds that you're not going to get to yet. But I just wanted to show you so that you know that they kind of exist. This is over here on the left, our sodium phosphate. This is a polyatomic ion, that phosphate. It works as one ion. So you would name that as sodium phosphate. This over here, iron is a transition metal. Like I said, you won't be asked to figure out what those are yet. But since transition metals can change a charge, they can have different charges. Iron goes between 2 or 3. You actually are going to use Roman numerals to tell what's the charge of that. So again, you don't have to worry about doing this now. I'm just kind of showing you this exists. So if you see it in the future, you're not kind of like, that's wrong. Okay, we're almost there. Naming binary, remember that means 2 different types of atoms, molecular compounds. This is much easier. Remember, molecular are covalent bond things, so these are going to be a bunch of nonmetals. You name them based on what are the 2 different atom types, just like we did with the ionic, but you're going to use these prefixes. So instead of worrying about what the charges are, you're going to actually have clues in the word or in the formula that tell you how many of each there are. So for example, here we have dinitrogen oxide, monoxide really. If this were ionic, you would just call it nitrogen oxide, right? It's covalent, it's a molecule, so you're going to use these prefixes. There's a list down here for you, and they're similar to what you would see in math, and you're going to use those in front of your words. So if we were to name the first part, the nitrogen, there are 2 of them. Prefix for 2 is di. So that's where we would get dinitrogen. The oxygen doesn't have a number next to it because there's only 1 of them. Prefix for 1 is mono, so monoxide. When there's already an O in front of it, like oxygen, we just leave that O. We don't call it monoxide. It's just monoxide. Then that's that. Only thing is when it's the first word, if there's only one of them, you don't use the prefix mono. You only use mono if it comes on the second one. So we'll do more of these two. All right, so before I do some examples with you of molecular, I just wanted to introduce the idea that there are lots of common names for things as well. So things like bleach, water, ammonium, citric acid. All of these are common names that we use for things, but those common names also have our chemical names as well. So we're going to start with water because we all know water is H2O, but we're going to name it as a molecular compound and see what we get. So I'm going to say, let's do H2O. And we know that's water, but they're both nonmetals, so we know this is molecular. So I'm going to use my prefixes. I have 2 hydrogens, so that would be dihydrogen. And I have 1 oxygen, so that would be monoxide. Another way of saying water. We could do another one. We have a sulfur, we have a fluorine. If I wanted to name this, we know these are both nonmetals. So prefix disulfur, prefix for 10 decafluoride. All right. So if you wanted to give yourself a cheat sheet, I guess, if it's ionic, it's going to be a metal and a nonmetal. All right. First thing you're going to do is find the charges. And you're going to balance the charges. Then you're going to write the element names. Change the last suffix to ide. So we'll use sodium chloride as an example, a metal and a nonmetal. Find our charges. That's group 1. That's group 17. They're balanced. There's a +1 and a -1, right? So if we were writing the formula, it would just be NaCl. If we were writing the name, it would be sodium chloride. There we go. For molecular, also known as covalent, right? These are going to be nonmetals. We don't need to count the charges, but we do need to figure out what are the prefixes. So find out how many of each atom. So determine number of each atom, right? Then we're going to use those to find the prefixes. Then we're going to write the element names using those. And We're still going to change that last suffix to "ide." So, example of this, we'll go back to if I had hydrogens, I had 2 of them, and I had oxygen. You don't need to worry about balancing your charges here. These are both nonmetals. So I know I have 2 of these. So that's going to be dihydrogen. I have 1 of these. Monoxide. If I gave you dihydrogen monoxide and you had to write the formula, you know the prefix is di. So that means you have 2 of those. This prefix is mono, so you know you have 1 of those. There you go. Last lesson of the year.